Hey everyone, welcome to This Explainer. Today, we are diving headfirst into an incredibly exciting moment in science. We're looking at the terrifying, yet honestly thrilling, possibility that our absolute best theory of the universe is fundamentally wrong. I mean, for decades, we've had this incredibly beautiful theory of the cosmos. It explained how everything began, what it's made of, how it behaves. It matched our observations so perfectly that we felt like, we had finally deciphered the cosmic code. But right now, that seemingly perfect code is fracturing right in front of our eyes. So the big question we have to ask ourselves is our perfect theory of the cosmos just breaking down? Because for the first time in ages, the universe is misbehaving badly. Thanks to some truly amazing new technology, our ability to look out into the dark is moving faster than it has in years, and what we're actually seeing is completely tearing apart our neat and tidy models. At first, scientists kind of brushed it off. They thought these weird observations were just silly mistakes in the data, right? Just noise that would clear up over time. But as our telescopes got sharper and more data poured in, the exact opposite happened. The cracks didn't disappear. They just grew larger.
Now, it's worth remembering that we've actually been in a cosmic crisis before. 2 centuries ago, astronomers realized the planet Uranus wasn't following the standard laws of gravity. But instead of just tossing those laws in the trash, they guessed a hidden dark planet was tugging on it. And boom, they found Neptune exactly where the math said it would be. The answer was simply more stuff. But then Mercury's orbit started acting up. They tried that exact same trick, but no new planet ever appeared. The answer that time wasn't more stuff. It was a completely new idea. Gravity had to be totally reimagined, which eventually gave us Einstein's general relativity. So as we look at today's unraveling universe, we have to keep asking, are we just missing some hidden stuff out there? Or is it time to literally invent entirely new physics? To figure that out, let's look at the evidence. We'll start with crack 1, cosmic monsters. For about 15 years now, we've been discovering massive structures out there in the dark that are just far too large to exist under our current physical laws. Get a load of these impossible cosmic monsters. We've got a giant arc of galaxies over 3 billion light-years wide, a massive quasar group spanning 4 billion light-years, a galaxy ring 5 billion light-years across. And check out that cosmic wall, a string of galaxies stretching 10 billion light-years long. Think about that. That is a whopping 10% of the entire observable universe end to end. Oh, and it's not just stuff that's too big either. We also happen to be living deep inside a local hole, which is this gargantuan 2 billion light-year wide cosmic desert with almost no galaxies in it at all. Now, you might be wondering, why are these giant structures absolutely terrifying to scientists? Well, it all comes down to the cosmological principle. This is literally the foundational assumption of all modern cosmology. It states that if you just zoom out far enough, the universe should be uniform. It should look like a smooth, even soup everywhere you look. Our models dictate that structures simply can't get arbitrarily large, and at distances beyond 1 billion light-years, everything should just blur together. But these giant monsters we just talked about, they completely shatter that rule. Under our current laws, they shouldn't even be there. Which leads us to a really chilling implication. It's like ants trying to guess the flavor of a cake while sitting on its only cherry. If the cosmological principle is wrong, if the universe isn't actually uniform everywhere, then we've got a massive problem on our hands. It means our tiny, limited view of the cosmos might not be a fair sample of the whole universe at all. Everything we observe, all the rules we think we've perfectly figured out, they might just be local weirdness. We could just live in a quirky cosmic neighborhood and completely missing the actual story of the wider universe. That alone is enough to give any astronomer a headache, right? But oh, the plot thickens. Let's move on to crack 2, dueling speeds. This second crack tears straight at the fabric of space itself. We know that space is expanding every single second. But the problem is, as we try to measure that growth, our math is spitting out 2 completely conflicting speeds. Imagine you're driving down the highway and you have 2 perfectly functioning instruments measuring your speed. Your speedometer reads 67, but your GPS clearly reads 73. You'd assume one of the instruments must be broken, right? But you check them again, and they both work flawlessly. That is exactly what is happening with the universe right now. We have different, highly precise ways to measure the expansion of space, and they simply will not reconcile. You're probably thinking, okay, maybe it's just a tiny margin of error. But look at the probability here. It's less than 1 in a million. As our measurements and calculations have become more and more precise over the last 10 years, the disagreement hasn't gone away. It's actually gotten worse. The chance that this expansion mismatch is just a simple accidental fluke is mathematically almost zero.
The universe is literally handing us two completely different answers to the exact same question. Something fundamental about how we understand the universe has to be broken.
And if you thought that was weird, just wait. Here is crack 3, impossible galaxies.
This is probably the most shocking piece of the puzzle, and it comes straight from the incredible James Webb Space Telescope. It has completely shattered a core part of our cosmic timeline. According to our expected theory, the universe started with the Big Bang as this amorphous soup of matter, right? It was supposed to take a very long, very slow process of tiny lumps of matter merging together under gravity to form anything substantial. We expected the very first large galaxies to emerge around 500 million years after the Big Bang. But then, James Webb showed us reality. We are seeing fully formed, massive, incredibly bright galaxies shining just 280 million years after the Big Bang. That is way, way earlier than anyone thought was even possible. Honestly, finding these early galaxies is quite literally like finding grown-up kids in a kindergarten. And it's not just that these galaxies are big, it's what they're actually made of. The baby universe was almost entirely just hydrogen and helium. But these super early galaxies already contain heavy elements like carbon and nitrogen. To get those heavy elements, you need entire generations of stars to have lived, died, and exploded in their cores. Finding them this early means finding generations of dead stars that simply shouldn't exist yet. It's really like walking into a preschool and seeing a bunch of fully grown adults sitting at those tiny little tables. It just doesn't make sense. So we have impossible monsters, dueling speeds, and time-traveling galaxies. What does this all mean? It brings us to our final section, the impending revolution. At this point, we're not just dealing with a fun, quirky mystery anymore. We're looking at a systemic scientific breakdown. Brace yourself to be a little visually overwhelmed here because the anomalies are coming rapid fire now. We are missing a massive amount of lithium. We're only finding a third of what our Big Bang models predict. Dark matter is apparently forming gentle hills in galaxy centers instead of the sharp peaks our theories absolutely insist upon. The mysterious force of dark energy, which we always assumed was a constant since the dawn of time, might actually be changing over time. And even our core interpretations of the cosmic microwave background, the oldest light in the cosmos, are suddenly under fierce debate. It is a radical, almost total unraveling of the cosmic models we've trusted for decades. But hey, I really want you to take away something incredibly positive from all this chaos. In science, crisis doesn't mean failure. It means the machine is healthy and working. This chaos is not a disaster. It's a massive triumph. Science doesn't move in a neat, straight line. It moves in cycles, long periods of calm followed by sudden, wildly confusing crises. When the experiments give results that don't fit, when the confusion grows and strange new ideas pop up, it is the incredibly exciting precursor to a massive revolution. The universe is basically screaming at us that our story is incomplete, and a deeper truth is trying to emerge. So here is the massive, provocative question we're left with today. Will we find a cosmic Neptune or a cosmic Mercury? Are we just missing some hidden stuff out there in the dark waiting to be discovered, or are our fundamental laws of physics completely wrong, requiring a radical new idea to explain the whole shebang? I don't know about you, but I find that absolutely thrilling. When the dust finally settles, the cosmos is going to be a whole lot more interesting. Thank you so much for joining me on this explainer. Keep asking those big questions, and I'll catch you on the next one.